So in this lesson, we're going to learn how to solve equations that have mostly variables for a single variable. So basically, we're just going to be rearranging variables and not getting a single number numerical answer like we're used to. Like this equation, since there's only one variable, we're just going to get a numerical answer, okay? This bunch of different variables, if we're still solving for x, that means we're just rearranging things and there's not going to be any like terms that we can combine. It may seem confusing, but I promise once this lesson clicks, these will be easier and faster than any of these because you won't have to do any calculations. So please ask questions in next class. In the beginning, it can be really confusing, but again, once it's clear and you ask all of your clarification questions, it'll click and it'll be way easy. Same thing on this side. You have multiple variables. They just ask you to solve for one of them. So we're not going to have any like terms, so we're just rearranging things. Well, the nice thing is the steps that we've been solving our equations like this, working backwards, like undoing the adding and subtracting first, then undoing the multiplication and division, will work for these problems as well. So like in 2x minus 5, if I draw the line to show the left-hand side and the right-hand side, if we want to solve for x, first we have to undo the minus 5, so we add 5. Okay? So we know the negative 5 and positive 5 eliminate, and we just have the 2x on the left-hand side, and we can combine 13 and 5 to get 18 because they're like terms. Remember, we always do like terms on a single side. So then we could divide by 2, and x equals 9. So my calculations, we added 5 to get 18, and then we divided by 2 to get your 9. Over here, I'm still going to draw a line to show the left-hand side and the right-hand side. If we want to solve for x, we want to get rid of the adding and subtracting first, then anything multiplied or divided by x. So first we're going to undo minus b. Well, the opposite of minus b is plus b, and we don't care what b is, we just know that negative b and positive b eliminate each other. And all we have left is ax on our left-hand side. Now on the right-hand side, c plus b, well, they're not like terms. We actually like that because then we don't have to calculate it, we just copy it. So we just copy the c plus b, they're not like terms, we can't do anything anyways. So ax, that means a times x, right? Because anytime we have numbers and variables right next to each other, it means multiplication. Well, the only way to undo multiplication is division, so we're going to divide both entire sides by a. Well, the side with x, a divided by a is 1x, but we just write x. But over here, we can't divide them. They're not like terms. We don't know what they equal, and that really doesn't matter. So we just keep it as c plus b over a, and that's our final answer. Okay. Now, in your notes, I want you to give me 2 sentences. Give me one sentence is how these two equations were similar in how we solved them. Then give me a sentence on how these two equations are different. It's what you do when you compare and contrast. So I want you to compare and contrast these equations. So I'm going to be looking for this in your notes. Now, 1 through 9, these are one-step problems. Basically, we only have one operation to undo to solve for the variable that they ask us to solve for. On the second side, 10 through 20, we have multi-step, which means usually we have 1 or 2 or more steps to actually solve. Okay. Now again, these can seem really confusing, but once it clicks, once you ask clarification questions on anything you don't understand, I promise these will become easier than the regular equations that we've been doing because we don't have to do any calculations. I promise. Okay. So let's do number 1. I'm going to do the odds together. So this is A equals L times W. This is a script font, so it seems kind of confusing. This is an L times W. We're going to solve for W. Well, the only way to undo multiplication is to divide, so we're going to divide by L on both sides. So that's my script L. So the L's divide out, and we get A over L, oops, was thinking of the answer. A over L equals W. Well, I don't like to write the single variable that we're solving for on the right-hand side, because we need to get in the habit of always having the variable we're solving for on the left-hand side, especially before we get into more complex like compound inequalities. Equals the A over L. So I'm going to keep this. From now on, I'm just, like when I'm at this step, I'm going to write the W on the left, or whatever is all by itself on the left side, and the part that we can't combine, because they're not like terms and we can't calculate A divided by L, and frankly we don't care to, we just copy it. So over here, this is D equals R times T, RT. So anytime you have variables next to each other, it means multiplication. Since we want to solve for T, that means we need to get rid of R. Well, how do you get rid of multiplying by R? You divide by R. So R divided by R is 1T, so I just get T equals, and then over here, D over R, we don't know what that is, and frankly we don't care. We just copy it. So number 5, even if you have multiple variables, so this is V equals L W H, that means L times W times H. We want to solve for H. We can do multiple, like L times W, we can get rid of that at the same time, and anytime you're multiplying, the way to get rid of or undo multiplication is to divide. So we're going to divide by LW as one whole unit. So we get H equals V over LW. Now look at number 7. This is M equals C minus S. It looks like a little 8, but you know when you write a cursive S, like they look like this? So they just wrote it without this first line. Okay, so just so you know, that's an S. But we're going to solve for C. So we want to get rid of the minus S. Well, we do that by adding S. Oh, and I wrote 8. We're going to add S to both sides. It does look like an 8, doesn't it? So again, the minus S and the plus S eliminate each other, and we get C equals, and I'm just going to write M plus S, and since they're not like terms, I don't have to calculate it. I don't care. I just copy it. And there's our final answer. Now number 9, solve for M. Well, if you notice, the equation is D equals M over V. Well, to undo dividing by V, we have to multiply by V on both sides. And on this side, I'm just going to write it as a fraction over 1. So I can clearly see that the denominator divides out with the numerator. And I get 1M equals VD, or I don't care, you can put it DV, because we know we want to write alphabetically, and multiplication is commutative. Like we can switch the order of multiplication and it doesn't change the answer. Okay, I'm going to have you do the evens in a second, but now let's look at the multi-step ones. So number 11, I have V equals 1/3 BH. Well, 1/3 times anything, like we learned in the previous lesson focused on fractions, when we multiply by a fraction, to get rid of it, all you have to do is multiply by the reciprocal. So we're going to multiply by 3 over 1 on both sides. Notice I wrote it as 3 over 1 on the side with the fraction, but over here I just wrote it as the whole number 3. Since there's no fraction, why bother? So on the right-hand side, the numerator and denominator divide out, so I just get BH, which we know means B times H on the right-hand side, and the left-hand side, 3 times V just equals 3V. Now, as a reminder, the directions for this specific problem, and they're going to give this different directions for every problem, tells you to solve for B, which means we need to get rid of H. Well, since it's times H, we get rid of it by dividing by H. So H divided by H is B. And then over here, 3V over H, we don't know what it is. We don't care. We just copy it for our final answer. Now on 13, we're going to solve for B. Now if you notice, here I'm just going to highlight, so solving B. This one's where it's a little bit different. Normally we do all the adding and subtracting first, we undo that first, then multiplying and dividing. But if you remember when we talked about order of operations, a fraction bar is a grouping symbol. So it's like there's imaginary parentheses around any other operations that are happening in the numerator and denominator. So what this does is tells us we have to get rid of the dividing by d first. Okay? So the opposite of dividing by d is multiplying by d on both sides. But because this is a fraction, I'm just going to put it as d over 1. That just emphasizes that the denominator divides into the numerator d. So we just get b plus c on the right-hand side. And this just becomes d times a, but I'm going to write it as ad because we want to stay in the habit of keeping things alphabetical. Now again, remember we're solving for b, so we need to get rid of the plus c. So we just do subtract c on both sides. So we get b all by itself equals, and then ad minus c. They're not like terms, so we just keep it ad minus c, and there's our final answer. Now over here in 15, this type of equation we're going to be doing a lot of in the next couple units, okay? This is actually what we call standard form of linear equations, and when we solve for y, we get slope-intercept form. And that may sound familiar to some of you, and some of you may probably have never seen it before, and that's okay, we'll just get to it. But we want to get rid of anything that's on the same side as y, because we want to get y all by itself. That's what solve for y means, to get rid of everything else on the same side. Well, if I just look at the left-hand side, because that's where y is, the furthest thing away is the ax. Since that's the adding, we need to undo that. The last thing we're going to do is divide by the b. So whatever's closest to the y is what we're going to do last. So the ax is positive, so we're going to undo that by doing the minus, or the opposite, negative ax on both sides. So we know the ax and the negative ax eliminate, so we're left with by equals, and I'm just going to copy the c minus ax. Because they're not like terms, I'm just going to rewrite it. Now by, to finish solving for y, we have to undo multiplying by b, so we divide everything, the entire sides, by b, and it divides out to get 1y, or just y, on the left-hand side, and we get c minus ax all over b for our final answer. Now look at 17. We want to solve for t. Now this is on the right-hand side. Well, t is stuck with r and p through multiplication, so that's going to be the last thing that we do. We have to undo the plus p first. And since p is positive, we're going to do negative p on both sides, or minus p. So it eliminates on the right-hand side. The left-hand side, we just can't combine like terms, so we just write a minus p equals prt. I guess this is a capital P, I better keep it capital. Well, now to finish solving for t, the prt means pr times t. So to undo multiplication, we're just going to divide by both pr in one step. So we get t equals a minus p over pr. Now look at number 19. Notice we're solving for f, but f is inside the parentheses. We could distribute the 5/9, but frankly, I wouldn't want to, because 5/9 times 32 is going to be messy. It's going to be an icky fraction. I actually would rather get rid of the 5/9. So this is like the lesson that we learned where you multiply by the reciprocal. So I'm going to multiply by 9/5 on both sides, and sorry it was kind of squoze in here. But if you see 9/5 times c, we just put them next to each other. But on the right-hand side, the 9's divide out and the 5's divide out because of the reciprocal. And since everything divided out that's in front of the parentheses, we don't need the parentheses, so it's just f minus 32. So to finish solving for f, we get rid of the minus 32, so we're going to add 32. And again, f is all by itself, but I'm going to write it on the left. And then 9/5 c plus 32, they're not like terms, so I just copy for our final answer. I'm going to go ahead and have you do stop the video, do the evens, and then check the answer key at the end of the video. And then when I look to check your notes, I'm looking for this quick write and all your work for the evens, okay? And bring any questions. I know, like I said, once this clicks and once you ask all the clarification questions, these will actually be faster and easier than the regular equations because you don't have to do any calculations.